In this video, we're going to look at another example of areas between curves. The question here is to find the area of the region bounded by the curves y equals arctangent x, tan minus 1x, y equals pi over 4, x equals 0, y equals 2. The first step, like usual, is to find the intersection points of y equals tan minus 1x and y equals pi over 4. So we're going to let y equals y and solve for x. So we have tan minus 1x is equal to pi over 4. Let's take tangent of both sides. So we get tangent of tan minus 1x is equal to tangent of pi over 4. Now tan and arctan cancel out and we get x is equal to, what is tangent of pi over 4? From the special triangle, tangent of 45 degrees is opposite over adjacent, is 1 over 1, is just 1. So we get x is equal to tangent of pi over 4, and that's equal to 1. Y is equal to pi over 4. So the intersection points are x equals 1, y equals pi over 4, but there's another intersection point we have to find. So let's plug x equals 2. This one is very easy to find. Plug it into y equals tan minus 1x. And we get y is equal to arctangent of 2. And that's the other intersection point. Let's put it in boxes. So that's the first intersection point, and this is the second intersection point. Alright, the next step is to sketch a region bounded by y equals tan minus 1x and y equals pi over 4, x equals 0, and x equals 2. Here we have a sketch. When you're drawing this sketch, it's very important to label your intersection points, because that's where the region changes and you have to describe the regions differently. Two separate definite integrals on the two separate regions. So the intersection point here, this intersection point is 1 and pi over 4. X is 1, y is pi over 4. And the second intersection point is x is equal to 2 and y is equal to arctangent of 2, tan minus 1 of 2. Now we have a choice of integrating with vertical rectangles and integrate with respect to x, or use horizontal slices and add them up in the y direction, integrate with respect to y. How do you make that decision? Well, it's definitely easier to integrate x equals tan y with respect to y, rather than integrating y equals tan minus 1x with respect to x. The difference being that integrating tangent of y is a simple U substitution. Integrating arctangent of x is a little bit more involves integration by parts. So we're going to do it the easy way. Alright, so we will apply horizontal rectangular elements and integrate with respect to y. Notice that when y is between pi over 4 and 0, the differential element dA is equal to tan y dy. So if you look at the graph, you can see when y is between 0 and pi over 4, the right x value is going to be tangent of y, the left x value is 0. That's why here we have tangent of y minus 0, so we just write it as tangent of y. Now, when y is between tan minus 1 of 2 and pi over 4, the differential area is going to be x right minus x left. X right is 2, x left is tangent of y dy. Let's illustrate from the graph. So you can see when y is between pi over 4 and tan minus 1 of 2, you can see that the right function is x equals 2, and the left function is x equals tan y. So the difference between that determines the length of the rectangle, which is 2 minus tan y. All right, so now we can set up the integrals. So area is equal to integral from 0 to pi over 4, tangent y dy. That's the first integral. That represents the area of the first region, plus pi over 4. That's y equals pi over 4 to y equals tan minus 1, 2. These are y limits. 2 minus tan y dy. So we set up two separate definite integrals with respect to y and add them up to find the area bounded. All right, so now it comes to the mechanics of actually solving this. So to solve this, the hardest part, I guess, is the integration of tangent y. So let's do that first. We want to integrate tan y. Let's find the general antiderivative. We're going to write this as sine y over cos y. Apply U substitution, sine y over cos y, dy. Let u be equal to the denominator, cosine y. Du gives us a multiple of the numerator, minus sine y dy. So what we get is integral of tan y dy is equal to integral. Sine y dy is minus du divided by u, because sine y dy is all replaced by minus du. Integrating 1 over u, that's log of u, because derivative of log of u is 1 over u. So we get minus log of absolute value of u plus c. Now replace u, put u back in, and we get minus log of cosine y plus c. We're going to use that. So the area is going to be the first integral of tan y, that's just minus log of cosine y, plus integrate 2. What is the antiderivative of the constant 2? That's just 2y. What's the antiderivative of tangent of y? That's minus log of cos y. Double minus is plus. We get log of cosine y. And the limits are from pi over 4 to tan minus 1, 2. And let's not forget the limits here from 0 to pi over 4. These are the limits of integration. Okay, let's apply fundamental theorem of calculus. We get area is equal to minus log of cosine of pi over 4. Minus gives us plus log of cosine of 0, plus putting the upper limit in for y, and we get 2 tan minus 1, 2, 2 arctangent of 2, plus log of cos of tan minus 1 of 2, minus 2 times pi over 4 is pi over 2, plus log of cosine of pi over 4. All right, so we do have to do lots of simplification. For example, cos of pi over 4, that's just going to be 1 over root 2. And cos of 0 is 1. Log of 1 is 0. And cos of pi over 4 again is 1 over root 2. Okay, so if we simplify this, we're going to get area is equal to minus log of 1 over root 2 plus log of 1 plus 2 arctangent of 2 plus log of cosine of tan minus 1 of 2 minus pi over 2 minus log of 1 over root 2. So let's simplify this. We get area is equal to minus 2 log of 1 over root 2 plus 2 tangent, tan minus 1 I should say, arctangent of 2 minus pi over 2 plus log of cosine of arctangent tan minus 1 of 2, close, close. All right, so a calculated ready answer would be area is equal to approximately 0.6931, carrying 4 decimal digits for accuracy, plus this works out to 2.2143. Pi over 2 works out to 1.5708. And log of cosine of arctangent of 2 works out to minus 0.8047. If we add and subtract all of those, we'll get area is equal to 0.532. This is the shaded area in the last page here, in this page here. So that's the shaded area. All right, thank you.